And it's a real pleasure to see so many people, although obviously perhaps not as comfortable for you, but I will do my best to make it worth your while. Okay, so I'm going to talk to you today about this paper that Colin and I wrote in JRME last year. And really the basis of this, we were kind of thinking about how do you think about the history of a scientific discipline. So I'm going to talk a bit about what philosophers say about that, how you can analyse how scientific disciplines progress. And then I'm going to introduce a method that we use for this study, using techniques from corpus linguistics and latent Dirichlet allocation topic modelling. And I'll say a little bit about how that works and what you can do with it. And then essentially what we did is we applied this method to everything ever published in the two big journals in mathematics education, and I think this allowed us to conclude, to sort of track the history of what mathematics educators have been interested in for five decades, and how that's changed over time. And I'll conclude with some sort of personal views on what that tells us and what the discipline ought to be doing differently. Okay. So if you want to think about scientific progress, there's various different ways. I mean, philosophers care a lot about this, of course, and I'm sure everyone knows about the Popper-Kuhn debate. I'm not going to go into this in much detail, but my preferred way of thinking about this is to use Lakatos's ideas of research programs. So Lakatos is most famous in mathematics and mathematics education for his proofs and refutations work, of course. But actually, he's much more famous. If you just ask some random person what Lakatos is famous for, they would say the philosophy of science and his notion of a scientific research program and how you can use that notion to understand how science makes progress. So I'll talk a bit about him. Here he is. He basically said that rather than, so Popper thought that science made progress through testing hypotheses, and then rejecting them and refining them and so on. And Lakatos said, no, that's not at all, that's quite wrong. It makes progress through research programs. So if you think about a scientific field, you can think of it as being made up of multiple research programs. Some of these are doing well, they are progressing. Some are not doing well at all, they're degenerating. And the key distinction between Lakatos and Kuhn is that Lakatos says you can decide which programs are progressing and which are degenerating through some kind of rational criteria. So science is a rational process, it's not mob psychology, which was his critique of Kuhn. So the basic idea here is research programs compete with each other to attract the attention of researchers. Right? And those that are progressing are going to attract more attention, those that are degenerating are going to lose attention and eventually disappear. And of course, every now and again, someone comes along and says, I'm going to propose a radically new research program, and if that's any good, it might attract some attention and take off. So you can kind of think about a field. This is the kind of picture I like to think about. Here are 5 different research programs, and you can kind of think about, here's a dominant research program. Right? So lots of people working in this program. There's a small niche program that is mostly ignored by everyone, but the people who are working in there keep sort of plugging away, hoping for the best. And maybe there's a new research program that's just come along and someone's proposed and it hasn't gained much attention yet. So this is a field, so you can think of this as being a map of maths education with various research programs of different sizes. Incidentally, if you're someone who I don't know what the situation is here, but I'm sure that this is an issue for you as it is in England. This kind of way of thinking about science really demonstrates quite clearly why citations are a terrible way of assessing research quality, because of course if you're working in this program, you're going to get loads and loads of citations, even if your work is rubbish, whereas if you're working in this one or this one, you're not going to get any. Well, you're not going to get very many, even though maybe your work is really, really important. And Donald Giddy's has a lovely book where he explains from a philosophy of science perspective why attention-based metrics such as citations really make very little sense when you understand the philosophy of science. Anyway, okay, so what is a research program? So Lakatos says, well, it's got 3 components. It's got a hard core, so it's got the key assumptions that everyone in the program is going to agree about. No one's going to dispute those. If you dispute those, you're not in the program. It's got a heuristic, which is kind of the techniques and the problem-solving methods, the standard methods that people in the program use to make progress. And it's got this interesting thing called a protective belt. So essentially the idea is, all the time, people are going to be coming up with anomalies to the program. So they're going to be pointing out observations that you can't really explain with the hard core. And Popper would say, well, what you should do in that situation is you should reject your hard core because you've refuted your hypothesis. And it turns out that no one actually does that. What they do is they concoct some kind of protective hypothesis to defend the hard core from falsification. So this is this belt of auxiliary hypotheses that you can just concoct on a whim, really. And actually, if you look at the history of science, there's loads of really clear examples of this. So my favourite is the discovery of Neptune. So people noticed that planets weren't moving in the right way, according to Newton. They weren't quite following Newton's laws. So if you were a proper Popper type scientist, you should have rejected Newton because the hard core wasn't working. Actually, they didn't do that. They said, oh, there's probably another planet that we can't see, which is a really clear example of an auxiliary hypothesis, which is a crazy thing to do, right? You think, oh gosh, this is making a really big assumption just to defend these equations, but they turned out to be right. Okay, so how can you tell if research programs are progressing or degenerating? So as I say, Lakatos says research programs are in a permanent ocean of anomalies. There's all these problems with all of them. And basically you can tell how a program is doing by how they deal with these anomalies. So progressing programs do one of two things. Either they're just so good and making so much progress that you can just ignore them. You just ignore these anomalies and, oh, I'll sort that out later. And that's okay because you're doing so much productive work elsewhere. Or they absorb them into their protective belts in a sort of positive way. So the way they absorb them yields new ideas and new predictions and so on. And you can contrast that with degenerating programs who are just consistently modifying their protective belts in this kind of defensive way, just to get rid of anomalies that would otherwise damage the program. And if all the program is doing is being defensive in this way, it's in trouble. And the idea is eventually, if you're working in a degenerating program, eventually the idea is you'll notice this and you'll give up. So here's a picture. I was quite proud of this animation. Here's your progressing program. Here's your degenerating program. Eventually, says Lakatos, this will happen. It's been a while since that happened. Yeah, good. Okay, so let's apply Lakatos to maths education. And I think it works remarkably well, actually. In particular, Steve Lerman's account of what he called the social turn. So Steve Lerman has this idea that he has this account of the history of mathematics education. In the 1980s, constructivism was the dominant research program. And I'll produce some evidence that shows that's correct in a minute. And then he didn't use this language, but basically what Steve Lerman was saying was in the late 80s, it encountered this anomaly that social factors seem to be really predictive of how successful students are at constructing schema in the constructivism sense of that word. So Lave famously does this study about how students behave differently in school from on the street. And then there's also an awful lot of work about how gender influences student success and social class influences student success. And that's pretty hard to account for from a classical constructivist perspective, which is all about cognitive construction of schema, so ideas and linking purely cognitive things. So here we have an anomaly, right? This is a problem for the constructivist hardcore. So what do the constructivists do? Well, actually, they just modified the protective belt in a really clear example of a defensive modification by saying, oh yeah, we should think about these things and we're going to rename our program social constructivism, which actually really didn't make much difference at all. And indeed, Lerman has this really influential paper where he says, well, this modification actually makes the whole program incoherent because you're thinking about knowledge in two different ways. In one way, it belongs in the head, and in another way, it belongs in the social community. So by doing this modification, you've made your program into a degenerate mess. So people should stop using it, was his argument. And indeed, he offered some evidence that that was the case. So he did an analysis of some papers in the 90s and claimed that what was happening was people were giving up constructivism and moving into what he called socio-cultural approaches, and he called this transition the social turn. And there's some debate whether or not this is continued through the, later on from the period Lerman looked at, although as we'll see later, it very clearly has. Okay, so what we were interested in doing, so that's just sort of a way of applying this Lakatosian framework to mathematics education, is can we do that in a more systematic, broad way? Can we identify the research programs that there have been in the 50 years of mathematics education research that's being published in international journals? Obviously the discipline goes back way before that, but that's kind of a nice point where the international journals came along. If we can do that, can we identify where there have been program shifts and what's going on now? So an interesting question is, well, how on earth do you do this? What methods can be used to do this? So people have used various different approaches to try and do similar things. So some people write sort of personal accounts of what they think is happening. Typically in sort of the 25th anniversary of a journal or whatever, they write some kind of personal perspective. Obviously that's very idiosyncratic. Some people take a sample of papers and do analysis of keywords or topics or what have you. And then some people use databases of papers and then analyse abstracts and this and that. So there's various different ways of doing this. We wanted to look over a longer time period than those kind of approaches allow and be a bit more systematic. So this was a method that I just happened to be investigating while on study leave. I decided I should do a MOOC because everyone was talking about MOOCs at the time. So I thought I should learn what happens when students do online courses. So I ended up doing this course on corpus linguistics just to see what it was like. It turned out to be very interesting. So I'll say what this technique does. So here's the basic question. Suppose you have a large corpus, which is just a collection of text, or a large collection of texts, sorry, papers in this case, academic papers. And suppose you want to know what the corpus is about, but you don't want to have to bother reading it. What can you do? So the basic idea of topic modelling is it tells you, it works out the main themes that are present in this large unstructured collection of texts. So if you're familiar with cluster analysis, you can think it's a bit like that, except on text rather than numbers. It's entirely data driven. Another way of thinking about it is as a sort of statistical version of grounded theory coding, where the algorithm does all the coding for you. So how does it work? Imagine, so you're trying to find out the topics that these texts are about. So imagine you know already what the topics. So what is a topic? It's just a distribution over words. So a topic is saying, well, look, if we have a topic about I don't know, seminar rooms, then chair, the word chair is going to have quite a high likelihood of appearing in a document about seminar rooms, whereas a tree is not. Okay, so the chair is going to have a high probability, tree is going to have a low probability, and then you can imagine similar kinds of things for every other possible topic. So if you have a load of topics, which is just a distribution over words, you can form a document by selecting a distribution over topics. So you can say, okay, we want to create a document which is 30% about seminar rooms, 20% about Auckland, 0% about trees, and so on. And then you can just pick words, right, from your distributions according to the correct probabilities, and you end up with a load of words. Obviously not easy to read because it's just in a horrible order. But if you think about documents as not having any word order, this gives you a very coherent way of writing documents. Okay, so topic modeling is basically doing that process in reverse. You start with a text. You say, I'm going to ignore word order entirely because it's too complicated. And you're going to say, I'm going to imagine that all of my texts were created in this way. What topics fit that best? So, let me give you an example. Imagine you've got two topics. Here's a topic about banking. So you have money, loan, bank, etc. Here's a topic about rivers. Notice it also includes the word bank. And I'm going to make some documents. So my first document is going to be 100% about banking. And it's just going to end up looking like that. Here's a document that's 100% about rivers. And here's a document that's 50-50. And what's kind of interesting is, even though that's the same word as that, the fact that that word appears in the same document as these words probably tells you it's that kind of bank, not that kind of bank. Okay, so I can go through and I can make my documents like that. But the situation we're actually faced with is just this situation where we have the documents and we want to work out what the topics are. Okay? And this latent Dirichlet allocation topic modeling is essentially just a statistical method for doing that. Okay. Any questions about that before I move on?
How accurate is it?
Well, you can be the judge of that when I show you the results. I think it's remarkably accurate, actually. But yeah, I was really surprised at how accurate it is. Okay, so it does have some assumptions. As I say, it relies on this bag of words model of text, which is that word order is irrelevant, which is obviously a radical assumption. It also ignores a lot of words that have no semantic content. So, you know, the 7% of all words in English are the, but that doesn't really tell you very much. So you just delete all of those, and then just do it on the words that have some content, some semantic content. So what's really nice about this is once you've got your topic model, you can then evaluate the linear combination of topics for each document. So you can say, well, document 3 is 40% topic 1, 20% topic 2, and so on. So why is this helpful? Well, basically, because hardcores, in the Lakatosian sense, and heuristics are defined by particular words, this ought to give us a way of identifying which hardcores and heuristics a given paper is using. And indeed, I would like to claim it did that very well. So, let's move on to the current study. What time did I start?
2 past. But not on their clock.
So we looked at these two major journals in mathematics education, ESM and JRME, both published at roughly the same time. They have slightly different, frequencies and so on. But I think most people would agree that they're the two most significant journals in the field. Here's some information about them. So they both published about 2,000 articles, at least when we did the study. And if you're interested in how many words they published, that's the answer. I don't know why on earth you would be. Okay, so what do we do? Well, we got all of the PDFs from their website. We converted them to text, which is a non-trivial task. We got rid of, publishers are really unhelpful for this sort of thing. They throw in loads of rubbish into the PDF. So we got rid of all of their copyright statements and stuff like that, watermarks and da-da-da-da. And then we did this topic modelling process. Now, one technicality here is you have to say how many topics you want when doing this. And this is probably more detail than you're interested in, but we use this perplexity model based approach, which is essentially a method of deciding how much detail you want in your model. So if you're familiar with factor analyses, it works a bit like a scree plot. So the basic idea is that you can trade off complexity with fit. So perplexity is just reverse fit, essentially. The more perplexed, the higher the perplexity, the lower the model fit. And by having more topics, obviously you can you can increase the fit, but you would be doing so at a cost of the complexity of your model. And one important criteria, as in factor analyses as well, is how interpretable the topics are. So you can see if you fit these models with various different numbers of topics, here is a model with only 10 topics, and that's really got quite bad fit. Here's a model of high perplexity. Here's a model with 100 topics, and that's got quite low, and you can sort of work out where some kind of elbow occurs. And we concluded that 35 topics was a reasonable place to interpret our model. Okay, so we have 35 topics. So what I mean by that is the mathematics education literature is about 35 things. Although some of those things weren't very interesting. So some of those things were instructions for authors. So in answer to your question, this method identifies all instructions for authors and throws them in the same topic, which is kind of a nice special issue announcement. French was a problem because, of course, French papers are much more similar to other French papers regardless of what they're about. And there aren't many French language articles in those journals, but they used to publish a few. So we had 7 topics of that sort. So that meant we had 28 sort of topics we wanted to interpret. So what do? So we gave names to those topics by looking at the words that have high probabilities in them, and then also looking at the papers that score particularly highly on them. So if you want to object to our names, that's perfectly legitimate, but the words that define those names come from this algorithm. But the names we've given them are our interpretations of those words. We then picked the topics that seemed to us to be related to the hardcore or heuristic of a particular research program, and that's what I'm going to talk about now. Okay, so what is mathematics education about? So here are some topics. So here's a nice example. So this is a topic about addition and subtraction. And you can see that if you write a paper about addition and subtraction, you tend to use words like this. So you'll tend to write about children, and then you spend a lot of time talking about number, addition, and counting and so on. And then you can think, well, which paper ever published in these journals had most of its words, had the highest proportion of its words from this topic? And it was a paper by Barudi in the 80s about counting strategies for addition. So that all fits quite nicely, okay. So the ones I've highlighted are the ones about research programs. So here's a constructivism topic. Now, you may not think it's obvious from the list of words that that's about constructivism, although the fact it's written by Steffe and Thompson ought to be a clue. But if I put up the top 5 papers from the constructivism topic, you can see hopefully pretty clearly that this has picked out papers that are really about constructivism. And indeed, I think of the top 10, 9 of them were by Steffe or Cobb. So what do these numbers mean? This means that this paper, 72% of its words, once you've deleted the, at, is, and so on, are about constructivism. Okay, and that's not too surprising because it's a reply to Steve Lerman's paper where he says constructivism doesn't make sense anymore. Okay, so that's our constructivism topic. We also had a didactical theories topic, which is kind of a continental European approach to doing research. Here's the papers from that, and you can see this kind of makes sense. Some of them are from special issues on that kind of approach to doing research. I think everyone in that list is either from France or Spain or Italy, which is where that approach to research tends to come from. So that's another research program that we've identified with our topic model. Here's some more. This one surprised me. So this is a topic about, which we ended up calling discussions, reflections and essays. And if you look at, this is another kind of, surprised me that the method allowed you to do this, but if you look at the top 5 here, they are kind of reflective discussion pieces, so letters to the editor or comments on other people's work, or observation on citation practices. So they're not researchy, but they're kind of reflective pieces about research. So again, the fact the method can identify that kind of paper, I think, is in its favour. Then we had a topic on experimental designs, and I think it's pretty clear from the words there. You can see that test group, significant, experimental, treatment, and so on. We had a topic on formal analyses, which was a surprise to me. So it transpires in the late 60s and early 70s, people used to do really odd research, I think, in the sense that they used to try and model classroom situations with group theory. So here is a... sorry, that's the experimental line. So here is... so here's a formalisation, a mathematical formalisation of Piaget's, some notion from Piaget. So this was an approach to mathematics education research I just had no idea existed, because no one does it. So that, again, I think that's kind of a nice result from the method. Here is a heuristic topic, observations of classroom discourse. So papers with high proportions from this topic tended to just be observations of things going on in the classroom. So quite a lot of these words are pretty clear. This one's kind of interesting. So it's is in that one. Why is it's in there? Okay, it's because if you write it's in your paper, a copy editor is going to correct it to it is, unless it's in a transcript. And here are the words. Here are the top articles from that topic, and all of these. If you read all of these, you find that they really are very heavy observational, just observing stuff in classrooms and talking about it. Then we have a topic on semiotics and embodied cognition. Now this is exciting. Here is a paper from Auckland, which is the most semiotics and embodied cognition paper ever published, Mike. Congratulations. You are stereotypical.
So good.
I don't know. So if you look at those, the top papers there, you can see all of these papers are about gestures or semiotics of signs and symbols and so on. So 67% of Mike's paper is from that topic, very high. We also had a sociocultural theory topic, which were these papers. Lots of these were actually from the same special issue on sociocultural theory, so that's nice. And then we had, these are sort of content topics, which I'm not going to talk about in this talk. Okay, so one thing you can do once you have all of these topics is then you can go and look at sort of famous papers you're very familiar with and look at the anatomy of those papers. So here is Toole and Vinner's concept image, concept definition paper from 1981. And according to our analysis, 54% of that paper is about analysis, and 24% is discussions, reflections, and essays. And indeed, it is a paper about learning about continuity, and David Toole does write in a very essay-like way. I don't know how he'd respond to me saying that, but I think that's a fair comment. Yackel and Cobb's paper on socio-mathematical norms, according to our analysis, is 42% about observations of classroom discussion and 27% about constructivism. And again, they come from a very social constructivism perspective, and that was a paper where they observed how people behaved in classrooms. So that seems quite promising, and you could go through and do that on various other papers. It's kind of interesting to see if it fits with your impressions of the content of those papers. So, now we're on to the meat. Once we've got that, we can then go through each paper, calculate those anatomies, and work out what's changed over time. Okay, so in the next few slides, I'm going to show you some graphs of those topics that I highlighted, so the ones that identify Lakatosian research programs, and show you the mean proportion of each paper published in each year, and show how that's changed over time. Okay, so this is the observation of classroom discourse. This is a heuristic topic, and you can see no one used to do that in the 70s, and now it's gone up and up and up. Now, one issue here is it's kind of hard to interpret these numbers, except within each graph, because some parts of papers are going to have more words. I'll come on to that in a minute, but all you really want to do is interpret these points in relation to each other. So that's a very clear trend. People are doing a lot more observations of classrooms than they used to. And that, I hope, fits with your impression of the field. This is sociocultural theory, and this is kind of interesting, because here we have a journal difference. So again, not a thing in the 70s, and then took off in the late 90s and 2000s, mostly in ESM, but also in JRME a bit. Okay. This is semiotics and embodied cognition, an even bigger journal split. So you can see this again is a topic that used to just not be a thing and has grown quite substantially in recent years. So an interesting question is, well, what were people doing here if they weren't doing these? Well, they weren't doing didactical theories either. And again, this is less surprising that there is a journal difference here, because ESM is a European journal and JRME is an American journal, and this topic is really focused. Well, most people who work in it are from continental Europe. So this is more interesting. So think back to the Steve Lerman social turn hypothesis. He was saying that constructivism was totally dominant in the 80s. And then around the mid-90s, it fell off and people stopped using it. And that's kind of what we see here. So nowadays, it seems, if you believe this analysis, constructivism is about as popular as it was right at the beginning of the 1970s. And I'll show you some more data on that in a minute. So that seems to fit Steve's account. This is the slow decline of reflection in the field. People used to do a bit more essays than they currently do. Formal analysis, this is the mathematical modelling of classroom situations and so on. Again, used to, and look at these numbers now, right? So in the 70s, 15% of all words, apparently, in papers, in ESM, were doing this kind of formal modelling. And now very, very, very few people do it. But this is the thing that really interests me, and I'll say a lot about this in the discussion, is the collapse of experimental designs in the field. So in the 70s, 40% of words in JRME were about true experiments, so randomised controlled trials and so on. And now, it's essentially zero. Okay. So I'll say a bit about that in a minute. So here are two discussion points in the time we have left that I'll touch on. So one is about the social turn, and can we provide empirical evidence for Steve's claims, and then what I'm rather provocatively calling the experimental cliff. Okay, so let's recap. So what did Steve Lerman say? He said, well, social constructivism is incoherent. Sociocultural theories should replace it as a way of thinking about learning, and then did an analysis a few years later and claimed that that was happening. Some people said maybe it's not carried on. So across both journals, that's what's happened to constructivism, and that's what's happened to sociocultural theory. So you can see really, really clearly that Steve was right about that, and has carried on being more right as time has gone on. And indeed, constructivism is really a very minority pursuit these days, the same level as it was in the 70s compared to the heights of the 80s and 90s. Okay. So people who worry about this kind of... So essentially this was Peter Gates saying everyone should do more sociocultural theory because no one's doing it, and I think he's just wrong about Okay, so on to my opinions now about the experimental cliff. So this is the biggest trend by far in these data, right? So as I say, 40-odd% of words in the 70s were about experiments, and now essentially zero. That looks like it's mostly been in JRME. The trend is really, really serious in JRME. But if you only plot ESM, you get a similar kind of pattern. This is because I was fitting cubics. I don't think that's a real trend upwards there. So you see this massive drop-off in both journals about experimental designs. The numbers are this. So across both journals, you can see from 22% down to 1.5% of words. So this is really fascinating. Why has this happened, and is it a good thing? Are questions that I would like to pose. So firstly, what are experimental designs? Well, there's various different names for this. So Cobb calls it the Experimental Psychology Research Program, which I think is a reasonable terminology. So let's stick with that. So if you read various personal accounts of why this happened, people put forward various different proposals. So there's this historical review by Clements and Ellison published in the mid-90s that basically said, I mean, it has this enormous rant against hypothesis testing, saying it just doesn't work and which I think from a modern perspective is not very persuasive. Saying that researchers lost faith in hypothesis tests and that they objected to what they called the straitjacket of experimental designs. And then if you can sort of look at the history of letters to the editor in JRME. Oh, sorry, I should say, yeah, other people disagree. So other people have completely separate accounts. So Kilpatrick says no, it's nothing to do with hypothesis testing or dominance of the program. It's because it didn't successfully influence practice, which I think is a criticism you could level at every program, really. So let's look back at some discussion in JRME in the late 70s about this. So there was a lot of discussion about how it ought to be possible to publish qualitative research. So here is a letter from David Rappaport, who says, well, so this is a relatively new journal at this point, only about 10 years old, less than 10 years old, and he says it's a successful journal, yet I find it necessary to assert that research in mathematics education is not a boon to further progress, but in fact an impediment to progress. The effect of statistical studies of global comparison is to lose sight of the child as an individual and to consider him only as a member of an aggregate or collection. His score is thrown into the hopper of that all-important statistic, the mean. So this is a reaction against this dominance of experimental designs. And then other people have this is a sort of reflection on this a couple of years later by Lester and Kerr, who say it's really important that in our trainings, in our doctoral programs, we train students in non-experimental techniques. So they want there's this call for diversity of techniques. So they want people to be trained in teaching experiments, interviews, protocol analysis. This training should be in addition to the study of experimental design and statistical techniques that they already receive. And then they go on and say it's really important that you should be able to publish both qualitative and quantitative research, and diversity is a good thing. So it's kind of interesting how, you look back on this from a modern perspective and you think, gosh, this is really crazy. This is all people do now, right? So this call for diversity really failed. So sorry. Rather than that just going down a bit and qualitative techniques going up, it dropped to essentially zero. So what happens to all the people or the experimental designs research program is an interesting question. Did it just get abandoned? And actually, I don't think it did at all. There's an awful lot of work on mathematics learning from an experimental perspective. Let me prove that to you. So if you do an analysis of psychology articles, searching for those terms, so basically I'm looking there for experimental psychology articles that are about mathematics learning, you find this. So, in exactly the same period that mathematics education lost interest in experiments, experimental psychology dramatically gained interest. And I say dramatically, the numbers here are kind of really tiny as a percentage, but actually they're not tiny in real numbers. So experimental psychology is an enormous field. So 89 articles met those search terms last year, which is more than was published in JRME and ESN together. So this is actually kind of strange. What's happened here is our field used to be interested in doing this work, has lost interest, but another field has taken over the research program. So as maths education has lost interest in experimental psychology, experimental psychologists have gained an interest in maths education. And you can demonstrate this in other ways as well. So this is a new society that was formed last year, had a conference in Oxford, the Mathematical Cognition and Learning Society. And it has a journal, the Journal of Numerical Cognition, which was also set up only a few years ago. And it's largely, but not entirely, populated by psychologists rather than education researchers. Okay, so you can kind of think about this trend and you think, well, is this a good thing or not? And Lakatos's methodology of scientific research programs kind of can help us think about this. So the first thing to say is his methodology doesn't actually deal particularly well with these kind of migrations between fields, which is an interesting critique of him, I think. But he does help us think about whether this might be a positive or a negative. So, remember what I said at the start. So Lakatos said that progress in a discipline comes about when research programs are competing for researchers' attention. Okay? Because that spurs on progress, it identifies anomalies, and seeing how programs deal with anomalies is the main way you can test whether a program is progressing or degenerating. And Lakatos got criticised a bit by Feyerabend, but not on this point. So if you're worried about me just uncritically using Lakatos, don't be. So both Lakatos and his critic said that the most effective anomalies for a research program are going to be generated by researchers working in rival programs. Because obviously they've got an incentive to criticise and to really poke holes in the assumptions that people from within the program are going to make. So the point is, program diversity is really, really good as long as research programs are challenging each other and critiquing each other by identifying anomalies. So an interesting question is, well, how could this work in the current situation? Because the programs appear not to be interacting very much, at least in the sense of which journals they publish in, at least the experimental psychology program. So if you've got researchers working on the same topic from different programs, reading disjoint sets of journals, it's really hard to see how this Lakatosian progress is going to happen. And I think this is quite an insightful way of thinking about this, is to contrast this with the previous big shift. So if you contrast, so the shift from constructivism to socio-cultural theories, all of these people who identified anomalies were really well known in the mathematics education community. So some of them did PME plenaries, lots of them published in journals and so on. So they really were known to the field. Whereas I think the current situation with experimental psychology, that's not the case. So, for example, let me give you a tangible example of the kind of anomaly that I think we're not thinking about because of this disconnect in the literature. So there's a lot of work in mathematical cognition on what people call core knowledge, and I think this is a really clear anomaly for the socio-cultural program. So the idea here is that there's core knowledge of mathematics that is present at birth, shared across cultures, including isolated tribal cultures that have no contact with Western society, and is also shared with some non-human animals. So there's idea, and this is stuff to do with the magnitude perception, numeric number sense, and so on. And there is some evidence, although this is controversial, but there's some evidence that this core knowledge is the foundation of mathematical competence. So this is really significant. If that turns out to be true, this is a really, really important area of research. And it seems to be really hard to conceptualise this properly from a socio-cultural perspective, which says that knowledge is constituted in social groups rather than in individuals. I mean, it's really hard to see how that possibly could be true if it's present at birth, shared across cultures, and shared with animals. So it seems to me that's an anomaly. I'm not saying that's a knockdown criticism of a socio-cultural research programme, but it's something that socio-cultural researchers ought to be thinking about a lot and working out how to accommodate in their protective belt, I think. And I can do anomalies the other way as well. So I think socio-cultural researchers have done an awful lot of work on micro-identities. So in particular, there's a lot of work in America on how ethnic minority students behave in classrooms and how microaggressions can change their moment-to-moment identities. And I think that's a real challenge for experimental researchers who assume that in experimental context, you assume that those kind of moment-to-moment changes can't happen, otherwise all your stats go wrong. So again, I think that's a reverse example of an anomaly that experimental researchers ought to think about. Okay, so let me summarise. If you had to sum up maths education in 5 bullet points, you would say this. People started off doing mathematical analyses, then they started doing experimental psychology, then they moved into constructivism, then they briefly moved into social constructivism, then they did lots of socio-cultural theory, and these days they do all sorts of stuff. So they do some kind of diversity is really the dominant thing here at the moment. So lots of people do socio-cultural work, lots of people do tactical work, embodied cognition and semiotics and so on. But I think this is pretty misleading because experimental psychology didn't go away at all. It just migrated away into a different set of journals. And I think this is really bad because of what I've told you about the philosophy of science. Also, from a purely practical point of view, this is certainly true in the UK. I don't know how true this is here, but there are entire funding bodies in the UK that only fund experimental work, and they've got the most money. So lots of people who are working in our discipline are missing out on that because they don't really engage with this kind of work. Thanks.
Well, thank you, Matthew, for a really stimulating talk in this shoebox. You did very, very well. We've got a few minutes for questions, so would someone like to ask something of Matthew? Mike.
I may have missed it, Matthew. I did look at your paper a while ago. Technology, there's an awful lot of stuff written about technology over the years, but it doesn't come out as a topic, does it?
That's an interesting point. I can't remember off the top of my head. Maybe it didn't, no. So why would that be?
That's my question.
Yeah. I mean, it could be. So there's no technology there. I mean, it could be because people who work on technology. So there was a dynamic geometry. Right? I don't know how persuaded you are by that, but you know, so that was more than just geometry. Definitely, it had stuff like logo. Yeah, I mean, it could be. I don't know, I've always been a bit suspicious of technology. You know, if you're working on dynamic geometry, is your work about technology or is it about geometry? Right? If you're working on computer algebra systems, so it could just be that actually people who work on technology are much more mathematically oriented than technology oriented. And I suspect that's probably the case if they're publishing in a maths education journal. Because as you know, there are loads of technology journals which are really focused on technology. So that might be an explanation. But as I say, I mean, when you do this kind of analysis, you can, it could well be, if we'd have chosen, topics over here, that number of topics, you'd have got a load, one might have fallen. So there's always this trade-off between, how simple you want your overall model and how detailed you want your overall model.
Free.
Matthew, how did you decide on that 37? Is it? I can't see how far.
35, yeah.
30.
So the idea behind this is exactly the same as the screed test in factor analysis. Now, if you kind of squint at this, so yeah, I mean, essentially what you do is you piecewise fit two linear regression lines. You say, I want to have two regression lines, where's the cut going to be? And it transpires on this graph, the cut is there. Now, you know, it's actually a pretty curved line, so I don't want to kind of give the impression that this is the correct way of doing this. You know, this is an exploratory analysis technique. It's a data reduction technique. You can do it in different ways, and you get very slightly different answers. I mean, we interpreted all of the reasonable possible ones, and more or less the overall picture was the same. So it doesn't vary a great deal. You get slightly different topics split, but yeah.
Lisa?
Yeah, I'm wondering about kind of the impact of the neoliberal world we're living in, and the fact that as an individual, when you choose your journal to publish in, on one hand you want to pick, you know, on one hand you might be inclined to pick one of the best two journals in mass education and talk to your mass education community. But if you've got the chance of getting that really high impact factor journal, that maybe your experimental psychology article could get published in, maybe there's certainly an individual advantage in choosing that one.
Well, that's interesting actually. So it depends on what system you work in. I mean, so and what metrics people care about. You know, so in my university, people are much more concerned about source normalised impact factors than impact factors. And actually, on those, JRME has a higher one of those than cognition, for example. So, you know, it depends on what system you're working in. Yeah, I mean, maybe you're right. I don't know. It's interesting to see working out the sociology of where people choose to publish and what to work in is an interesting topic. I mean, the reason we chose these two journals in particular is, well, firstly because they're very clearly the top two in the discipline, but also they were started at around about the same time, which makes the analysis much simpler. You know, if you threw in a newer journal that only had been publishing for 10 years, that kind of skews everything in a slightly hard to interpret way. You know.
I'd follow up what you said. I'm published in both, but I chose which one I would publish to, depending on the topic and theoretical framework. Yeah.
Yeah. No, absolutely. No, I'm absolutely right. Yeah. So what I find interesting is it used to be possible, maybe it still is, but much harder. People used to choose to publish experimental psychology work in mathematics education journals, and they don't anymore. So why, you know, if that's down, I don't know if that's down to, so I wouldn't want to make a claim about why that's happened. It could be down to the journals being less receptive, it could be down to the researchers thinking, no, I'm going to get a better audience elsewhere. Who knows, really? But either way, I think it's bad.
Could there be more cross-discipline collaboration as well? So I've worked with psychologists, and so we published in some non-maths education journals.
And why did you do that?
Because of their contribution, I think. They write in quite a different way.
Yeah. But, yeah, okay. I mean...
We've done both, I mean, in maths ed and in...
And published experimental...
Yeah.
So it's pretty rare, right? I mean, I did a special issue on experimental work in 2015, and for the editorial for that, we systematically went and read every article it was published the year before, and only 3% of them used experimental design, so it's really rare. No, obviously there are examples. Yeah, but...
Folks, I think we might stop there. Maybe to catch up with Matthew in the remaining time he's here. Next week, colloquium, 4 p.m. Wednesday.
Yeah.
So you're most welcome to attend that as well.
Where is it going to be?
It'll be in...
Yeah.
Yeah. It's on the posters. You must have passed about 85 posters on the way through.
Slightly.
So thank you very much for your attendance. We will try and find a bigger venue next time. But in the meantime, thank you so much, Matthew.
Thank you.